Great. Thank you, Bob. So Bob is Senior Vice President of Research, and he's the Chief Analyst for Computing at Hyperion Research. He helps drive the research and consulting efforts in the US, Europe, and Asian Pacific markets for technical servers, supercomputers, clouds, and high-performance data analysis. Bob also advises a diverse and international client base on the global HPC sector status and prospects through strategic research projects, single and multinational government studies, international competitive research analysis, and technical trends analysis in the HPC hardware, software, and infrastructure worldwide. So thank you very much, Bob, and we're ready to get started.
Great. Thank you, Susan. I appreciate the invitation to talk today and to participate in what I think really turned out to be a very, very interesting and compelling study. So we might as well jump right into it. You know, as the title says here, we're looking to talk to some of the quantum computing early adopters, the end user organizations that have already started some particular kind of quantum computing activity. And we'll get into what we define as an early adopter, what we define as a quantum computing activity, and also some of their hopes and dreams and realizations that come from being a quantum computing early adopter. But before I do, I want to tell you just a little bit about Hyperion, not as a commercial, but more so people attending can understand a little bit of how our perspective on quantum perhaps be a bit different and unique from some of the other players who are looking at the sector. Ultimately, when you dial back about 5 or 6 years, the reason Hyperion Research got into quantum, not because we saw it as something that was an industry that we needed to track, or even the quantum industry approaching us to kind of start to inform and help them on their journey. But it was really from our pedigree as a purveyor of high performance, or more appropriately, advanced computing developments. The idea of the sector from an end user perspective, the organizations that are always looking for the next big boost in performance capability, whether it be multiprocessors, shared memory, chiplets, HPC to the cloud, AI powered by GPUs. It's always looking for the next level of performance. And so we started getting questions from our HPC user base, asking questions about what's the story with quantum? Is it real? What's the time frame for adoption? And most importantly, what can quantum bring to our overall compute environment? What applications can be accelerated? What performance gains can we anticipate? And more importantly, what new applications can we bring to our overall workload composition that can help us do our jobs better? So the pedigree here, the history, is more about looking at quantum not as a standalone sector that exists distinct and apart from the classical advanced computing world, but how it can integrate and what it can bring to the overall prospects for advanced computing capabilities writ large. So with that definition in mind, let me just move through quickly into really what the study objectives were that we undertook. Well, I guess it's been about 4 or 5 months since we started the study. It's now complete. We have a document that is a bit more formal in treatment that I know is available from D-Wave that you could download, and if you can't find it there, just email me and I'll send it along. But so this is more or less of a written deck that encapsulates some of the findings of the major written report. But really, what we did is in conjunction with D-Wave, we wanted to get a better understanding of the challenges and opportunities experienced by early adopters of commercial quantum computing, and what the goal of that, why we undertook that activity, was really to understand from the early adopters' perspective the growth and expansion paths within these organizations that have taken their first step. What were some of the lessons learned? What were some of the criteria they used to actually decide which kind of quantum computing they would have, how they justified it, how they selected it? And in some cases, which I thought was one of the most fascinating aspects of this effort, is how quantum came to be part of their overall computational vision. Who were the key influencers that said, hey, we really need to be thinking about quantum? Who were the shakers and movers within these early adopter organizations that said, this is something that we probably should be looking at? And so we'll be sharing some data on that as well. Well, let's just jump right into the executive summary. I'll give you a flavor of how the study went and some of the major findings, and then we can get into the details as we move along during the course of this hour. And what was interesting is we found that there certainly are a wide range of quantum computing related activities currently underway in the commercial sector. And what was interesting is we set a goal where we wanted to talk to 300 different quantum computing early adopter companies And we really had no idea how many organizations we would have to reach out to hit that goal of 300. And what we found is we only had to go to about 485 organizations, meaning that about 62% of the companies that had some selection criteria, which we'll get into in a moment, 2/3 of them basically were already looking at quantum in some capacity. Quantum is definitely high level of interest within a wide range of verticals in order to at least understand what's going on in quantum. And so if we look at a little deeper what we meant by quantum related activities, what we found that about 34% of the companies that we talked to are exploring options and monitoring technology. And this could be as simple as having a recent hire in quantum chemistry spend an afternoon a week looking over the literature, understanding what's happening perhaps in the commercial sector, and trying to figure out if the technology is evolving to the point where it should be raised to be more of a budgetary item within a company. We found a number of organizations that were actually conducting use case analysis. About a quarter were looking at the idea of maybe we understand what quantum brings, but how can we take advantage of that capabilities within our specific vertical, within our specific use cases that are either unique to our company or perhaps common to our sector. But how do we start to think about adopting quantum capabilities to our specific workloads? And we actually found about 14% were engaged in what they called production use. Now that number struck me as high at first, and we started kind of scratching our heads a little bit and talking to some of the folks that are involved in this process. And what we figured out here is that one of the main issues of quantum right now is its virtue of being very easily and somewhat cheaply accessible via cloud access model. It's not that difficult to set up, in some sense, a production use capability. Now, granted, in some cases, or perhaps in many cases, you're not betting the company's future on the particular production use of quantum today, but at least you have already started, most likely through some kind of cloud access model in a small scale way, to move some of your production business case operations and running them on a quantum system and basing some of your decisions on what comes out of those results. Now, let me be clear about the whole issue of quantum advantage and quantum superiority and such. There have been very few limited cases of demonstrable quantum advantage, cases where quantum computing can clearly outperform classical counterparts in a real world use case. But the one thing is certain is that the trajectory of quantum means that those quantum advantage examples will be coming soon. It's hard to predict exactly when, but most of us think within the next couple of years or so, there will be significant demonstrations of quantum advantage for some useful use cases, some of them in the production environment. So that's why we think that 14% use case number in production is a realistic one. It's the easy barrier to entry, and it's the anticipation that as the technology evolves, that production right now, which is almost in essence a test bed, will become more heavily used in terms of its production and product. One of the things we found is when we asked about what was the value driver that got your organization into quantum, it was really about enhancing business efficiencies. The ideas of taking some workflows, perhaps something is the way your factory is laid out. If you've got some very expensive advanced manufacturing tools in your production facility, and you just want to figure out how to arrange the floor space to minimize the transfer of materials, the flow of the jobs, and also the arrangements of your most expensive equipment, all the way to things such as optimizations of scheduling for resource allocation. The idea of if you're, say, a large airline, and you're trying to figure out exactly how to keep all your planes in the air for the longest amount of time, on the ground for the minimum amount of time, and merge that with the rigorous requirements of scheduling for all the personnel, pilots and flight attendants and mechanics and such that make that happen. So the business efficiencies right now, optimization in some sense, I think is really one of the greatest attractive elements within quantum right now. However, about 1/3 of the respondents cited, if you combine the two, improving research capabilities and driving innovation. And the reason I add those two is I think in some case they really go hand in hand. No one does research for the sake of research, and innovation certainly is driven by advanced research capabilities within an organization. So there's certainly this emphasis on the fact that quantum, while it can help improve business process, the idea of driving innovation, energizing your research capabilities, perhaps even opening up new lines of research is a reason, a value driver to bring quantum into your overall computational complement. If you looked at some of the organizational drivers, it was really evenly divided. The reason that organizations were looking at quantum is divided between they want to be able to accelerate some of their existing classical workloads, the jobs that are running now that are either stalled out to some extent, or at least becoming increasingly expensive as it becomes more and more difficult in the classical computing world to drive computing gains. We're seeing a lot of leveling off due to certain trends within the classical computing sector, the so-called ends of Moore's law, the end of Dennard scaling, concerns with moving down process nodes and perhaps sub 5 nanometer lithographic processes. Process progress in those sectors are slowing down a little bit, and a lot of organizations are looking for new ways to accelerate their existing classical applications that maybe classical hardware can't deliver over the next decade. And also the opportunity to adopt new quantum computing workloads. What are some of the new technologies? What are the new enablers? And here, again, optimization. Looking at optimization processes that heretofore were intractable on a classical system that in a few years could be quite simple and easily calculable on a quantum system. So some of these new workloads are also offer significant promise, and that's really what's driving a lot of these companies as well. And the bottom line here is that these early adopters see the promise of quantum not for a narrow range, but really for a wide range of computational workloads. We saw interest in machine learning applications, a lot of interest in finance-oriented optimizations, things like portfolio management, pricing derivatives, thinking about options strategies and such, and also, as I mentioned earlier, logistics and supply chain management. Continuing on the executive summary, one of the things we saw, and this was a really interesting finding, I believe, it was one of the greatest hurdles to quantum computing adoption was complexities with integrating quantum computing into the existing IT infrastructure. And I don't really think that this was based on hardware, the idea that how are we going to bring a system on to say either our on-prem facility or access it through a cloud access model. I think here the concern is really about merging quantum computing capabilities from a software perspective with existing classical IT infrastructure. And like I said, what surprised me was not some of the demands of quantum computing specifically, perhaps in terms of programming, dealing with use case analysis, those kinds of technical aspects. It was really more about the integration process. How are we going to bring this in and take advantage of quantum computing without having to completely disrupt or really upset our existing classical IT infrastructure? The other one, of course, is clearly demonstrating ROI. It's the issue of how can we justify this economically? How can we not just kick the tires, but really get in the driver's seat of quantum computing and demonstrate that to the C-suite, to the folks that actually write the checks? So what I found interesting is that the complexities here, the greatest hurdles, were not purely technical from the quantum perspective. They were much more classically oriented, and they were much more business oriented, which means that at some level, quantum doesn't have a technology problem as yet. It has some other larger holistic issues as it moves to become, as I said earlier, a part of the overall IT computational infrastructure, not as a standalone phenomena. One of the things that I thought was interesting and is kind of the complement to that thing is when we asked about what was the selection criteria that you used to pick your particular activity that you're involved in right now. And the big one was really sector-specific skills were valued. And again, vendor ability to integrate into the structure, the existing IT infrastructure. So that falls back to the idea that a lot of quantum computing early adopters, and we think further on end users, they're not going to have the in-house capabilities to do this integration technique. They're going to look to either the vendors or quantum computing professional services to help leverage that quantum computing capability into their existing IT infrastructure with a minimum of upheaval. What I found interesting, though, is some of the things that the quantum computing sector tends to dwell on, perhaps a bit too much, are issues like qubit modality. Well, I've got trapped ions, they've got superconducting qubits. Those guys are looking at NV centers, and these are some of our qubit specifications, our T1, T2 times, and some other things. Those tend to be very low importance for vendor selection criteria, and I think that makes a lot of sense. Some of those numbers are confusing. There's no standard benchmarks for those technologies right now. It's difficult for the uninitiated to really understand exactly how to make a choice based on things like qubit specifications and modalities. It's certainly not going to be a case where we have benchmark capabilities in the next few years to help clarify those things. So right now, those are relatively unimportant. I almost have started calling it qubit fatigue, the idea of more announcements about we now have X number of qubits and our number of qubits is greater than their number of qubits, and our superconducting qubit is better than their trapped ion qubit. As I said, the interesting thing is the sector itself Those are the deep concerns they need to progress the technology. But from an end user perspective, they're just simply not viewed as critical. And the last thing is from the key summary perspective was we saw a lot of positive QC adopter plans for the next 2-3 years. More than half are looking at measured growth. They are in this for the long term. They're committed to continued funding. They actually we'll get to one graphic that talked about how they felt about their current quantum computing activity, and we found that 98% of them said it was either very or highly successful, that they were satisfied with the work so far, how quantum has progressed within their company. And so what that means is that really only a small number, we found about 2% of organizations said, well, quantum really hasn't lived up to its expectations right now, and we may not even be looking at funding in the future. But as I said, a large number are looking at either measured growth in terms of commitment of revenues, and 1/3 see very aggressive growth, and we'll get into details of that. Well, because it's important if I'm going to be studying a lot of if I'm going to be citing a lot of statistics as a confidence building measure, if you will, I'd really like to just take a few minutes to tell you, well, who are the folks that we talked to? What is their composition? What do they like? So we can at least get a sense of who they are and why they answered perhaps what they did. Well, one of the things we did was, as I said earlier, we basically said, do you have some form of ongoing quantum computing efforts? And you must have had to answer yes to that question. And if you didn't, that ended the survey right there. And as I said earlier, we had to go through 485 respondents to get out 300. That's only 38% of a kick out, which again indicates that there was widespread quantum computing activity within the companies we found. And the goal here was to really hit upon the United States and specific key quantum computing adopter nations right now, and the ones we chose here. So I'm pretty happy with the geographic distribution here. We had a little less than half in the United States, but we really kind of walked our way across some of the critical EU markets and the UK, and this is kind of the distribution of where we went. So we convinced ourselves this is a relatively decent distribution here. We're trying not to just be US centric, because if there's one thing this sector isn't, it's US centric. This is a global phenomena from not only from both, but from a supplier base, from an end user base, from a government program base, and from a venture capital funding base. This is not US. Every nation that has some kind of every nation that we're really tracking right now has some kind of significant commitment to quantum computing, whether it be through government programs or corporate funding or end user interest. This is not domestic. This is not US only. There's a lot of activity going on around the world. So when we tried to really find out, okay, as I mentioned earlier, what are some of the activities? How do you define an ongoing action? And the way these charts will go is generally the one line will give you the combination, and then where it's relevant, we'll divide up between what we saw between the US and what we saw between the European respondents. There's not a lot of differences in many cases, but where there are, I'll try to call them out. And as I said earlier in the key judgments, what we found is about a third are exploring options and monitoring technologies. Use case analysis is going on by about 26%, about 1 in 4. What I found interesting is that the use case analysis and prioritization here was slightly higher in Europe. And I think what that means is what I see when you go to some of these European quantum computing conferences and such compared to the US, there is much more tight integration between government programs, quantum computing suppliers, and quantum computing end users in Europe from a programmatic standpoint than there is here, perhaps in the US, or certainly different than what's going on in China. So I'm not surprised that we're seeing a little bit more use case end user participation in European organizations right now, simply because that's baked into a lot of the early government early government projects. But this gives you a span of activity that we found going on in some of these organizations, just to let you know what we mean by ongoing activity. Now, another thing that we used as a cutoff, I remember I said there were a couple of selection criteria for the companies. We wanted to get companies that had more than $15 million in total revenue, and I think it was $5 million in IT budget, because what we were trying to do was really find organizations that had the financial wherewithal to really act in some significant way on quantum computing. And so this is really just a breakdown. As you can see, is our largest European group. We talked to companies $1 to $5 billion of estimated 2022 revenues. US companies a little smaller, $500 million to $1 billion in estimated 2022 revenues. But the bottom line is about a quarter of the companies we surveyed greater than $5 billion in annual total 2022 revenues. And this is the IT budgets. Largest European group, 25 to $50 million IT budget, US 10 to 25 million. But again, about 1 in 5 had $50 million or more in IT budget spending for 2022. Now, it was interesting, and this is a key feature of the study, was casting a broad net across as many verticals as we can. And this is a breakdown of the kinds of business that these companies self-identify them as, given the list of choices that we put here. And you can see about a quarter of all companies that we spoke to were in the financial service sectors. Otherwise, 14% were software and internet. Quantum computing companies about 7%. It's not a dirty little secret, but it's perhaps a not well-known or understood fact that the quantum computing sector right now is a significant consumer of quantum computing resources. Hardware companies are looking at software. Software companies are interested in hardware. So, if at least in the early days of any sector, it has to feed its own requirements to further its own corporate research agendas. So that number is there's quantum computing companies out there who are involved in quantum computing research outside their particular line of business. But the key takeaway from this particular graphic is again the broad range of companies that we were able to say, hey, do you do quantum? And they came back and said, yes, we do. There's very few you'll see down there. Defense, geoscience, and weather and climates. We're really the only organizations where we couldn't very easily identify companies that said, yes, we're quantum computing early adopters. So it's really, to me, this chart speaks more about the level of activity, how broad it is across a number of major verticals. And this is a pretty comprehensive list of verticals. When we asked about the computational capabilities that these organizations currently have, you'll see that basically HPC research environments and HPC production environments were about 50% of the overall composition of respondents. About a third were what considered themselves mixed HPC and enterprise, and about 13% viewed themselves as enterprise IT shops with some HPC or related computational research capabilities. To me, one of the takeaways here, which I'm still trying to figure out, is it seemed to be difficult, if not nearly impossible, to find a quantum computing early adopter that didn't consider itself to have some form of HPC or otherwise advanced computing capability. So in some sense, the idea of pure enterprise locations looking at quantum right now, they may be holding back a little bit. It's the HPC in research environments and mixed shops who are really looking at what quantum computing can do. And that kind of cycles back to my initial comments about how we were brought into quantum very early on because of questions from our HPC user base. And so this really kind of just reinforces the fact that there right now is really seen a reasonably tight linkage between what's going on in HPC in terms of existing capabilities and interest in quantum computing capabilities to bring that into the fold to basically enhance their overall computational compute complement. As I mentioned earlier, we were trying to figure out exactly who are the people that drove quantum computing adoption into their particular sector. How did they, where do you locate the folks that are driving some of this stuff? So we tried to find out what we call the quantum computing influencers. Who are the folks that basically consider themselves a technology influencer when it comes to the process of technology adoption, not limited to quantum computing, but basically new technology adoption across a broad range of potential technologies. And we asked them, well, how much time do you spend each week doing that kind of job? And we found that these kind of self-identified influencers spend about 1 to 3 days a week exploring new technology prospects. And we found about 5 to 7% of the people we surveyed said, this is my full-time job to do this. So the quantum computing adopters who are driving some of the early adopter enthusiasm are folks whose fundamental job in some way is significantly committed to looking at new and emerging technologies, which I think is an interesting aspect of the idea that the most progressive companies, the ones that commit resources to looking for advanced compute capabilities or other technologies to further their overall business or value objectives, they have folks who are interested in and committed to this. And when we ask those influencers, well, you say you're an influencer, but how often do you really think that you have made some kind of active role in determining what happens, what direction the company takes in new technology? And what we found is that basically the majority of influencers, about 40%, do that as a continuous part of their job, that they are constantly involved in the process of technology adoption, or at least playing a role in recommending what's going to be going on. And the second largest group, around 30%, which means you combine those two, you're basically at 70%, or almost a very high percentage. Weigh in about 3 or 4 times a year, which to me means about once a quarter. They're weighing in on some interesting or compelling technology adoption. So when we ask these influencers, well, what specifically is your job title? And I think it's pretty straightforward. I don't think we're terribly surprised that we saw a lot of CIOs, IT directors, or CTOs, but those are really only about half the people we got. There were also a number of influencers who had job titles that didn't really say this is the kind of influencer that you'd expect. And you'll see things like data center staff, hardware engineer, data scientists, non-technical staff, some of the other non-technical folks lower, but at least measurable. What I find interesting is that only about 12% overall, and only 6% in the US, had the word quantum in their title. So it's not that you can clearly identify someone who's a key influencer within a quantum computing adopter by their job title. You really have to dig deep, because the technology hasn't evolved yet where the end user has really gotten to the point where you could say, here's our quantum computing division, here's our leadership. It's really more an evolving state of play. So I did find that interesting. So let's jump into the early adopter perspectives here. As I mentioned earlier, what was the greatest value driver? And we found that really enhancing business efficiencies was a big deal. Things like increasing revenue, improving research capabilities, competitive advantage, things like reducing time to market, realizing cost savings versus optimization. Those two time to market cost savings were not considered as a more important value driver as some of the other things I mentioned. What was interesting is I found that Europe was about twice more interested in competitive advantage than what we saw in North America. And you can see on that line where 20% of folks in Europe said that achieving competitive advantage was important, while only 11%. And I think that again speaks to the emphasis in the European market of the end user looking at this not as a technology, but perhaps more as a way to advance an end use sector. For example, if you look at an EU program, their quantum programs are designed to say, okay, let's transfer technology directly to make our aerospace sector, our automaking sector, our advanced manufacturing technology sector more competitive from a global perspective. So that's why I think the competitive advantage activity in Europe came in at almost twice what's going on in the US compared to North America, and conversely why North America was much more interested in the research activities. They still do this perhaps a little bit more as a potential technology to be explored, as opposed to something that could be directly and immediately driven by a use case advantage. We asked about the organizational drivers. Again, this goes back to that what I mentioned earlier, is that faster existing workloads and new QC workloads are really the top of driving quantum computing adoption. But there's a lot of options here in terms of influence, things that you had influence from your research staff, your influence from your IT staff. That goes back to some of the job titles we talked to earlier. But what was interesting is this is not just about early adopter philosophy. These are not companies that go out and grab every bright, shiny object that comes along. We only found about 1 out of 4 that said that. And if you do the addition here, you'll see that we gave them the option to pick all things that drove them. But the idea here is that the traditional early adopter attitude and the fear of missing out issue, the idea that, well, we're here, we don't know why, but we know that bad things could happen if we aren't. Those do not seem to be an overwhelming driver right now from an organizational perspective. It's really about tackling existing workloads and opening up opportunities. And when we asked them about some of their most promising workloads, again, we saw a wide range of interest here. Machine learning applications, finance-oriented optimizations, logistics, supply chain management, modeling and simulation, manufacturing, factory process, quantum chemistry, and such. What's interesting is, almost all of these options were selected by approximately 30% of the respondents. It's as if there is still a broad range of perceived capabilities in quantum, and everyone is open to the potential for quantum across a broad range of application spaces. People are not zeroed in on particular things. They're exploring the range. They're not saying, well, if it's not machine learning, I'm not interested. They're also interested in looking at some of the other aspects of quantum. So it hasn't really congealed yet into a very narrow range of stovepipe workloads, it's still a wait and see, or at least a let's see what the field offers in general. When we asked about their current activity, was it successful? Was it unsuccessful? Almost no respondents viewed current quantum computing efforts as unsuccessful. There was certainly, if you look at the numbers here, you'll see about 98% say that it was either very successful, some unsuccessful. Not a lot of unsuccessful activities there. But what I found interesting is that we saw very few that said too early to tell. What this tells me is that there is a general sense of, I think, realistic expectations about what quantum is and where it is in its technology and commercial trajectories. And so people have the expectations, and they can actually make a decision that says, this is pretty much what we expected to see at this point in time, and it's fine with us. And I think that's a really interesting point, because one of the problems, or at least concerns, that some have within the sector is expectations that can't be met realistically in the near term. Has the sector overpromised, and is the potential for under delivery there? And what this gives me is a certain amount of confidence that the end users have a sense of where the technology is going, and how fast or how slow it's moving, but they're at least sanguine with the current state of play. And so if I saw a lot of uncertainty here, like, oh, we really don't know if this is exactly what we were expecting or not, that would give me a little bit of concern. But the fact that most of them thought it was successful, and all of them thought that they were in a position to judge appropriately the progress, means that the end users have at least a general sense of where the technology is going right now. Now, again, this is the point I made earlier in the key findings, is the greatest hurdles for QC adoption: complexity with integrating into existing IT infrastructure, and concerns with demonstrating ROI. These, again, are two very business-oriented phenomena. Then you get into other things, limited QC vendor options, which I think is a reasonable expectation right now. Vendors are not offering full product lines where you can go in and kind of pick the machine or access method you want. It's still a nascent technology, so that's a fair thing. I think one of the ones that I would call out was lack of in-house expertise and domain knowledge. Not a lot of end user organizations have an existing quantum computing in-house staff. I don't think they see that happening very much in the near term. Their quantum computing workforce is a continuing problem. The sector itself has enough trouble finding qualified candidates, much less end users being able to bring in quantum computing experts to address in-house capabilities. And the other thing that goes along with that is domain knowledge. The idea that it's one thing to offer a quantum computing system, it's another one to offer a system that is suited to the language and concerns of, say, the oil and gas sector versus the financial sector versus the aerospace sector. And so it's domain knowledge issue of basically being able to fully understand the specific end user vagaries, if you will, of a sector, or even down to a specific company, is something I think is going to be a reasonable amount of concern, which is why I think we're going to see a certain amount of uptake in what we would call quantum computing professional services. Organizations that are neither hardware or software suppliers or end users, but form the consulting and professional service bridge between those two organizations, where organizations can step in, advise, implement, and then move on to the next customer. So I think quantum computing professional services is going to become an increasingly important predictor of the potential future success of the technology. When we asked about the selection criteria and how did you deal with the organizations, the quantum computing suppliers that you're looking at, again, no surprise, if my biggest concern is integration in IT, the ones I'm going to go with are the ones that offer the best opportunity to integrate into IT. The thing I do like to point out is, if you look way at the bottom, you'll see that some of the qubit issues, things like quantum qubit modality options, qubit specifications and such, simply aren't nearly as important right now to a number of organizations as things like technical expertise, vendor software offerings, or vendor demonstrated performance advantage in key use cases. As I said earlier, those numbers haven't become widely available. It's going to take a few more years, but what this tells you is that the vendors that can really come out swinging in terms of demonstratable performance advantage in the work cases, in the use cases that matter to these end users, is going to have a significant commercial leg up compared to who's got the best qubit modality or particular hardware configurations or such. I think that's a key point to keep in mind when one starts to think about how you go about selecting a quantum computing vendor. It's not about their modalities. It's not about their technical performance per se. It's their ability to demonstrate performance and deliver that performance into your existing IT workload. We asked them about a little bit about their plans for the future. And you know, the good news here, I think is really important, is that more than half are looking at what I consider to be, we use the phrase measured pace with modest increases. And I think that that's a crucial element in the sense that the sector doesn't become overheated. We're all worried about, again, the idea of grand expectations that aren't delivered on. And so what this tells me is that the quantum computing end user sector has really grasped the fact that the solutions, the quantum supremacy issues, the easy answers aren't around the corner. It's going to take a little bit of time to get there. They're measuring their expectations, and they understand they're in sync with the progress of the technology. They're not expecting a universal error corrected gate model system with 1 million qubits in the next year or so. They understand that this is going to be a journey of engagement, and they're looking at the trajectory and potential of the technology in some sense more than they are looking for near-term hard proof today. And I find that to be a very satisfying outcome. Now, that said, about the thirds that we talk to are like, hey, we're moving forward aggressively. We see the technology, we understand its potential, but we think that there's actual potential benefit from actively and aggressively embracing quantum computing at this particular point in time. So the bottom line is, if you take those top two lines there, you see it's very good news for the sector. There's only about 13% are even talking about maintaining, and no one is really interested in looking at any kind of reduction or cessation of quantum computing activity within the early adopter stage. And I think that's overall good news for the sector and great news for the organizations that understand what these end users are really after within the next few years. And so with that, we asked them, okay, what is your specific anticipated annual budget? And we didn't say this year or next year. The question was phrased in a way that once you reach steady state, once quantum computing becomes perhaps like what GPUs are today in terms of AI in the HPC world, compute composition and such, where do you see your numbers coming out? And this gives you a sense of kind of the level of commitment from the sector, you know, from perhaps some of the smaller companies, sub $1 million, a lot of organizations looking at 1 to 5, say within the next 3 or 4 years or so. But there's generally a large tranche of organizations we spoke to that are looking at significant annual investments for quantum computing. The key here, though, is that there was really no consensus about a typical annual budget. And I was really loath to start looking back to map company revenues or existing IT budgets to slice this a little too thin. I didn't want to draw some false conclusion based on a limited survey set size. But you know, the bottom takeaway from this, no typical consensus, but a significant amount of money is perceived to be committed to quantum once it reaches a steady state of funding and such. Well, that was basically a run through of the study. As I said, the larger written version of this, or this deck, is available either through D-Wave, or you can write me at this email address and I'll zip a copy off to you. Or if you have any additional questions, work through D-Wave to get in contact with me, or contact with me directly. The study had a lot of different moving parts, and I'm more than willing to address any questions that are going on out there. But that's my particular take on the effort. I want to thank D-Wave for funding this and making the effort available. And really kind of leading the charge in my mind of looking at what I would call the quantum computing 1.0. There's a lot of organizations right down there who are at kind of version 0.1. They built the product, they've looked at the technology, and they've offered it, and they hope it becomes available or at least usable. Well, my perspective, D-Wave has started to move to that 1.0 version. They've introduced systems, they've built an end user base, and they're starting to take the steps to really understand what the critical end use capability is, moving this transition from a push sector where you just build a technology and you push it out the door to pull. Who are the organizations who are going to be adopting the technology? And more appropriately, what are their expectations for that particular capability? And how can the quantum computing sector respond to those needs? And as I said earlier, the key takeaway to all this is demonstrated use case performance over classical. It does not have to be quantum superiority. And in some cases, it doesn't even have to be quantum advantage in the sense that it's 50 times faster than your classical counterpart. It has to have quantum competitive advantage. It brings a competitive advantage to your overall research agenda, your innovation capability, your ability to drive return on investment and such, in a way that delivers performance not measured at the level of the quantum computing capability, but from an overall business perspective. And I think that's a key understanding here. And the other one, of course, is really thinking about is addressing the concerns of a user base that simply doesn't have the in-house technical capability to do the job. They're going to be looking to vendors. They're going to be looking to software firms. They're going to be looking to professional services to help guide them down the process. If there was a dream machine out there from an end user perspective, it would be a black box that no one in the company knows what it does. But whenever there's a call goes out to do a quantum calculation or a quantum program, the compiler or the OS knows exactly what to do, gets sent to the black box, and the results come back. That's really the ultimate vision here. As I said at the very beginning, just to wrap up, quantum computing is not a standalone capability. There's never going to be in a situation where quantum computing will significantly supplant classical computing capabilities. It is going to continually be viewed as a particular brand of accelerator for the advanced computing world for some narrow, I wouldn't say narrow, but perhaps targeted range of applications that are critical to the overall compositional requirements of a company. So think of it as a well-behaved accelerator in many cases that can really provide some significant value add from a computational and overall corporate perspective. Well, thank you for your time. I'm going to go back to Susan if we could talk a little bit about if we have any questions or anything like that.
Yes, we do. First of all, thanks, Bob. That was great.
Cool.
I also want to mention before we get started with questions that D-Wave's Qubits conference, that's Qubits, that we've been doing now for 7 years. It started out as kind of a small user group meeting. It's gotten larger and larger. And the last 2 years, it was entirely online and we had thousands of people attend. This year, it's a hybrid event, January 17th to 19th. Excuse me, with the first 2 days taking place in person and streaming from Miami Beach, and then a virtual tutorial day on Thursday, January 19th. We would like to invite you all to come either to Miami or online. And if you go to qubits.com, you can see the agenda. Bob is one of our speakers. You'll also be hearing from quite a few enterprises about their specific applications and quantum projects, including several interesting ones actually in production. So we hope you will attend. Before I get started with the questions, I had one kind of overall question for you, Bob. You've been at this now for quite a few years in terms of looking at quantum. What is your kind of overall view of how the kind of progress that's been made and what you've seen change over the past 5 years or so?
Well, the thing I've seen change most dramatically is a more realistic perspective on trajectory. 5 years ago, the idea of quantum supremacy, the Shor's algorithm specter of being able to break public-private key encryption was a big deal, and intractable progress compared to classical counterparts. I've started to see an understanding now that's going to take a certain amount of time for quantum to get to, but you shouldn't wait for that to happen. If you sit around waiting for that ultimate end machine, the holy grail, if you will, of quantum, you're going to be way late to the game. The idea is that the technology will move forward at a somewhat more measured pace than I think some people originally envisioned. Not the scientists, by the way, but I could argue perhaps some of the marketing folks had perhaps a little bit more enthusiasm than maybe the technology could evolve. And the user base, I think, started to pick up on that. They started to say, this is not just around the corner. This is something that's going to take a little time to roll out, and we're going to see some incremental gains. And as long as we see progress, that's good enough. The promise of the trajectory of quantum is good enough to get us interested in now. Maybe we can't demonstrate quantum advantage. Maybe we can't demonstrate ROI today, but we will soon. And if we wait too long, I don't want to say fear of missing out, but it's the fear of not being well informed that I think is the reality now. People need to start understanding not what quantum is, but what quantum can bring to their computational workloads, how it can address existing computational workloads, the classical world, and perhaps more importantly, what are some of the new applications that it can enable them to explore that heretofore they didn't even consider. So I think it's a much more realistic perspective of how the sector is going to advance and what you need to do to participate. One of the things that we look at is this idea of the specter of quantum winter. It goes back to the late 80s with this idea of AI winter, where you had tons of funding, tons of expectations that were unmet, and the sector went into a deep dive and a deep freeze, if you will, for almost 20 years before it was more or less resurrected, not from the original AI technology of the 80s, but through things like neural nets and other things that were GPU enabled, and NVIDIA had a lot to do with that. And some of the deep learning and machine learning algorithms were not what was considered in the early rounds of AI. So the specter of a technology with too much funding, too much expectations that are unrealized, is quantum looking at a quantum winter? And we've been tracking that question, and we're seeing a lot of moderation. People are a little more sanguine about the news. And what's interesting is the quantum computing supplier sector is more concerned about quantum winter than the quantum computing end user base. The end users, I think, understand this is going to take a little bit of time, where the quantum computing suppliers are a little more jockeying for position. They're jockeying for visibility, they're jockeying for funding, and the perceived gains in market share. But the bottom line is both sectors have moderated the idea of quantum winter simply because I think the message of progress and near-term viability of the sector has been more broadly accepted. And I think that's a really good thing. And so it's just a more realistic. That's why I love the idea of slow and steady growth. I love the idea of moderate expectations. And I think we've turned a corner on that idea that quantum is going to change the world tomorrow. It's going to take a reasonable amount of time. But the bottom line is, if you're not involved as soon as possible, you're not going to be well positioned to harness that potential capability in your own workloads.
Okay, thanks. And one other thing before we go to the questions, a lot of people were asking about getting a copy of the report or these slides. So I put in chat the link to the D-Wave website to get a copy of the report. And I will get the slides from Bob, and we will send out an email to everybody with a link to the slides so you can get those as well.
Great.
Okay, so some of this is kind of outside what you specifically talked about today, but it says, so these results are from the commercial sector. Are the needs applications of the government and research sectors different, and what are those applications?
Well, I mean, one of the things is that, and you know, there are some great government programs going on right now. I'm a huge fan of what's happening right now down at, say, Oak Ridge National Lab, the Department of Energy, where their research agenda is really targeted on what we would call hybrid quantum classical algorithms. The idea that you have not just an algorithm that lives on a quantum system, but one that literally within an iterative process, you've got, think of it as a do loop, where one instruction is do something cool on the classical side, and then the next instruction is now improve on that in the quantum side, loop again, and go back and forth between the two. And to me, some of the interesting work in terms of new algorithm development and more appropriately testing some of the quantum systems that are available right now within the government labs, I think is a really interesting one. But they just have an entirely different calculus in terms of their justification for revenues, their expectations, and ultimately their missions. So while it's interesting, we didn't want to get different results from either the government sector or the academic sector, because their overall vision of what they want to get out of a new technology is somewhat different from the commercial sector. But you cannot deny that, I mentioned a little bit about venture capital funding being a significant player in the quantum computing sector right now. We just completed a study sponsored by the Quantum Economic Development Consortium under the National Quantum Initiative. And we were looking at quantum computing suppliers' basic fundamental revenue streams. And we found that about 49% of the quantum computing companies that we could talk to, I think we talked to about 108 different companies, 50% of them had less than $500,000 worth of revenue in 2022. And of that, half had zero revenue. So we're looking at a sector right now that is still, they haven't entered the virtuous cycle of R&D generates products, products generate sales, sales generate revenues, revenues generate R&D. So government and VC funding and venture funding is, or corporate funding, are really the triad, if you will, of what's driving quantum right now. And the VC market is notoriously short term. They have a different agenda. And so the government funding right now is a very critical part in all this, because they are looking much more towards a stable and more predictable path of funding. And as long as there's government funding going on, some of these companies can look beyond just the next round of venture capital funding, having to go out and maybe go public and deal with some of the complexities of being a publicly traded quantum company, which attracts all sorts of interesting players in the field. So the government funding, and it's clear that this is a phenomenon, because every really interested, bottom line is there's so many government programs out there right now around the world. If you can't, I defy you to find me a relatively advanced compute nation that doesn't have a government program that at least is $1 billion worth of funding. You could just see it everywhere: Australia, Singapore, UK, France, Germany, Israel, and certainly China and the US. So the government funding is critical, but their agenda is somewhat different. And what we really tried to do was capture the vitality of the commercial sector, because ultimately that's the revenue base that will help this industry sustain itself. If you have to depend on government funding for too long, you don't ultimately end up serving the commercial sector well. And remember, the key element of quantum isn't the ability to do interesting math, it's the ability to generate economic vitality. That's really what happens when you get right down to it. So we wanted to concentrate on the organizations that really are the baseline of economic vitality, either within a nation or across a sector.
Great. We had two kind of application-specific questions, which again were outside the report, but based on your experience. Have you seen anything on investments in quantum machine learning in the area of electronic health records is one. And the other is what to expect from it regarding VFX animation workloads, and whether you've seen any of that.
Let me go to the first one first. Certainly, machine learning within the quantum space is one of the more compelling application areas right now. And I will tell you that I was up at a conference on Wall Street a couple of months ago, and was taken with the idea of so much of machine learning right now within the financial sector and related sectors is interested in looking at natural language processing. The idea that there's so much text out there, there's so much information that is textual in nature that organizations can't boil down, or they would love to have, what's the word I'm looking for, an oracle. So if I'm a stockbroker or a doctor, I think a doctor would be a better example, and I have a patient who's got a number of conditions and he's on a number of medications, it would be great to be able to sit down and say, is it safe to give this patient this drug? And because that combination of conditions and pharmaceuticals in that patient may have never been tested before, but through a machine learning algorithm that could be generated either on a quantum system or a composition of quantum classical, could actually be in a position to really test and experiment and look through a corpus of millions and millions of research documents, notes from hospitals, from other doctors, and come up with a yes, this is safe, or no, this is not safe kind of thing. So the idea of looking at machine learning to really examine text-based information for a wide range, and imagine the same thing with a broker who cannot simply understand all of the SEC regulations, what's happening, say, around the world, fast-breaking news, developments and things, saying, is this a good investment today? And the Oracle could come back and say, yeah, that's illegal. And this is why. And it goes back to a document that was printed 14 years ago and says, this is why we think it's illegal. So there's a lot of interesting work going on right now, I think, in machine learning tied into natural language processing that I think is really going to energize a lot of different sectors. I don't know if that answers the question or not, but I think it's a cool development. What was the second area?
VFX, now I lost it here. Let's see, sorry. VFX animation workloads, rendering, ray tracing, CPU, GPU computations. Not something I've seen, but
no, it's something I haven't seen, and I'll tell you one of the things that one of the issues with quantum here is the idea that you have an input, and the input it has to be classical. It's going to be bits, ones and zeros. Now, when you get in the quantum realm, you've got all sorts of wonderful quantum goodness going on. You've got superposition and entanglement and all these procedures and all of this physical phenomena that allows you to deal with complexity in a way that's really not available in the digital world. But when you're done with that quantum goodness, you have to eventually come back down to a classical output, ones and zeros. And what I find is that the classical example of that, of course, is Shor's algorithm. I feed a quantum system at some level of abstraction, a very large number. Lots of quantum goodness goes on to factor that number into its two essential prime numbers. What you get out is some insights into what those two prime numbers are. So very limited input, but the quantum goodness handles very deep complexities of that input. So in some sense, quantum computings are much better at complexity of interactions that don't require a lot of data I/O. And so when you're talking about things like digital content creation and such, that in some sense could be considered a much more of an I/O intensive operation. I'm not saying it's impossible, but the I/O-ness of things like having to put, 4K resolution at 60 frames per second is in some sense an I/O issue more than something like Shor's algorithm. So I'm not saying it's impossible. I'm just saying that there are additional challenges when you're dealing with I/O intensive operations versus operations where you have small I/O but complex interactions in the quantum realm.
Okay, we've just got time. We've got three questions that we can get to here.
I'll try to keep it short.
One should be quick. In this survey, is quantum computing inclusive of gate-based, quantum-inspired hybrid and annealing, or one of those only?
It's great. We made no distinction. We did not say it's got to be gate model. It's got to be a quantum simulator, analog quantum computer. It's got to be, an annealing system. We made no distinctions about. We just said quantum or not, and we didn't want to get into arguments about what is this and potential and future capabilities and such. So no, there was no distinctions made.
Okay. Here's a question. How should one be looking at and expect from quantum computing, i.e. be much faster, say 2x, 5x, 10x, and solving the problems in comparison to classical computers, or should it be used only for solving problems which are impossible to solve by classical computers?
All I know is, and this is the HPC experience, if I was an HPC vendor and I could walk into a compute facility and say, I give you 25x performance gains, the guy's getting his checkbook out as fast as he can. As I said, classical performance gains are becoming harder to realize. The most recent top 500 list, those big machines that sit at the top of the world's performance in the exaflop range, those are $600 million systems, and they consume enough power in the tens of megawatts that you could run up a $300 million electric bill during the life of that system. So the idea of exponential speed up or even quadratic speed up, those are nice and those are great goals, but I think the end user community, you give them 25x, you give them 50x. Heck, if the integration problems are manageable, you give them 10x, an order of magnitude of performance. The classical world's performance doubles every 14, 15 months now, but that's stretching out to about 2 years, doubling. You give someone an 8x performance boost, you're saying to them, I've just given you a 3-year boost in competitive advantage over your non-quantum competitors. I don't think that's anything to sneeze at from a overall workload perspective.
Okay, so we're just going to wrap up. People were asking about the recording. So this webinar has been recorded and it will be posted to the D-Wave YouTube site by tomorrow. So you can find it there. Again, we'll be sending out an email to everyone who registered with a link to the recording and to the slides. I put in chat where you can get the full report. Someone also asked about kind of a QC 101 primer. I encourage you to take a look at the qubits.com website and sign up for our day 3 tutorials on qubits. We have 4 hours of programming tutorials. The first 2 hours, there's a 2-hour block really focused on kind of intro QC 101 and another 2 hours for people with some experience on how to use the tools and how to create your first quantum applications. And also we have lots of training classes. If you go to the D-Wave website and look under training, we have week-long virtual training classes that you can sign up for as well. So with that, we're at the end of our time. Bob, thank you so much. Great
Thank
as
you.
always. And we
Great.
will see you in Miami.
Outstanding. Thank you very much, Susan. You have a good day now.
Everyone, thanks for coming.
Bye-bye.